Welcome to 27th lecture in the course of Industrial Engineering and Operations Research. We are discussing many things relevant to Industry 4.0. In the last lecture, I told you about big data, and we can make inference from big data by applying several techniques. Some classical statistical methods can also be applied, but I told that nowadays machine learning methods are getting prominence. So, therefore, today's talk will be focused on machine learning. That word machine may mean here the computer that which can learn by automatically by means of data. So, it is some people may say that it is part of artificial intelligence. Some say that okay, there is overlapping things between artificial intelligence and machine learning, but both are separate things. So, let us discuss machine learning. What is machine learning? So, one opinion is that machine learning is a branch of artificial intelligence that enables system to learn from data and improve their performance without being explicitly programmed. So, it can find out the patterns within the data. It involves using algorithms to analyze data, identify patterns and make predictions or decisions. Essentially, machine learning systems learn from experience as they process more data, becoming more accurate over time. So, they learn from experience. If you give the data, then they update. That is the type of machine learning. Just like human being learn with experience, similarly the machines also can learn with experience. So, this is, suppose you have some people say that this is AI and machine learning is a part of that. Okay. So, this is ML, but some viewpoint can be that there may be AI, okay, that AI is here and machine learning is without AI also can be there. Okay. That is machine learning. So, anyway, that is not so important here right now. So, machine learning word was started in around 1959. Samuel said that it is the field of study that gives computers the ability to learn on their own. Computers are machines and they learn on their own. So, machine learning algorithms learn the pattern from past data sets and apply the same to new or unseen data sets. If you have got some information about say something, okay, like suppose you have y and you have got x, for each x you have got y, this information you have, and then you find out that for unknown x what will be y. So, this is also can be done by machine learning. We have been fitting by straight line, but we can that is also a small part of machine learning only. There are many algorithms like that. So, machine learning algorithms learn the pattern from past data sets and apply the same to new or unseen data sets. Machine learning uses probability theory, statistics, linear algebra and calculus for drawing inference. Meaning can be utilized. So, machine learning is not only statistics, but it can use linear algebra and calculus also. It is a branch of artificial intelligence, allows computers to learn from data without being explicitly programmed. So, it is quite generic in nature. One machine learning package is there, it can be used to solve many problems. So, it uses algorithms to identify patterns and make decisions. Why machine learning has become very important today? Now, it has become important because now it powers many modern technologies, search engines. You see that many search engines are there, like Google is there. You find out, you give some search something and then immediately it gives some web pages. those type of things can be done very fast by means of the machine learning. It also gives recommendations. So that is also based on by seeing my behavior, it will give recommendations. Suppose I go to Amazon site and I keep purchasing few items, then by machine learning algorithms my behavior can be understood that what type of thing I am ordering, and therefore Amazon site will give me recommendation that this is also one product for us. Similarly, when we see any YouTube video, you see that in the bottom it shows many other videos, so that I can browse over them also. Those type of things can be done. Similarly, voice assistants, machine learning can help in many things. Voice assistant also, in fact, it can translate also, and if I am speaking something by machine learning algorithm, it can be converted to in other language, and also it can be slightly modified. Machine learning automates and improves decision making. We make the decision, but suppose we have got 1000 data, it is very difficult to go through each and every data and then make a decision. So machine learning will help me to make the decision. It helps discover insights from large data sets. If you have got large data sets, then what is the meaning of that, what is the average, what is the standard deviation, what we learned from data, what is the pattern, all those type of things are coming through machine learning algorithms. It automates tasks. Many tasks can also be automated, not only decision making, but even actions can be automated, and it finds patterns in data. So in manufacturing, machine learning methods have been applied. Benefits of applying machine learning in manufacturing are as follows. Machine learning algorithms has the ability to handle high dimensional data. Otherwise, you have got so many factors, so many parameters, but with the help of machine learning algorithm, you can keep track of that. Machine learning can help discover unknown patterns in data set that was formerly unaware. So therefore, even suppose there is a machine and it is fitted with number of sensors, and each sensor is giving different type of information, then it can understand that whether what is the machine's condition. So it can be used in condition monitoring also. You can say that, okay, normally these type of signals I was getting, but today I am getting different signal. That means there must be some defect in the machine, like that. And manufacturing systems are dynamic and uncertain. Machine learning helps learn from such dynamic environment and help in decision making. If you take the help of any handbook to decide the machining parameters, etc., these will not tell you that suppose machine starts vibrating due to some wear and tear in the machine, or machine has become old. So that adaptability is not there, but with the help of machine learning algorithm, that adaptability will be there. But there are many challenges. It is not easy to make some machine learning scheme or machine learning based model. There are many issues. First is that you need the relevant data, because as we said that machine learning is a method that where machine will learn from the data. So naturally that it has to be, you need data. Without data, how you can train the machine learning algorithm? So we need to have acquisition of relevant data. Data should be reliable. Therefore, what we have to do, we have to do pre-processing of the captured data. It is not that whatever data you get, you start using that. You have to remove outliers, and you also have to maybe pre-process it. Suppose you got too much data, sometimes you have to prune the data, sometimes you have missing data, you have to assume the data. So these type of things have to be done. A suitable ML technique to apply on the captured data set, you have to apply a suitable machine learning techniques. Nowadays problem is that so many techniques are there, and therefore it becomes very difficult to choose one technique for solving the problem. Then interpretation of the results obtained, proper interpretation of the results has to be done very carefully, proper algorithm has to be there. So that's why these are the challenges. Now in the current manufacturing scenario, many things are there, lot of competition is there. So we want to improve the machining efficiency, we want to improve, lower the cost. So following are the major goals of the manufacturer: higher machining efficiency, he needs high machining efficiency, less energy consumption, because for sustainable manufacturing practice that environmental concerns are there. So you should, if you consume less energy, that means you are helping the environment, because for energy generation you have to take some resources from the environment, and also you pollute the environment also. So lower cost, we need lower cost also, and then we need high quality of the product. So main aim of implementing machine learning in modern day industries is to ensure a cost efficient running without compromising safety. Now we have key performance indicators. Suppose I am giving the example of machining. So we have got some key performance indicators, we say KPIs, key performance indicators, that by which we know the performance of machining. They can be cutting tool temperature, surface quality, they can be directly analyzed using past data as well as real time data based on the controllable and uncontrollable variables. So we can in machining we can apply the machine learning, so that we can get the cutting force, cutting tool temperature prediction based on maybe parameters, cutting speed, feed, depth of cut, and also based on vibration, etc. Then proper implementation of big data in manufacturing can drastically reduce the product development time and other costs associated with it, as reported in one study. This is given here. So big data with machine learning can be an asset. You can get lot of data. You have been operating machine for years and years. Suppose some machine is running since last 10 years. Naturally, you can know its behavior if you have preserved the data properly and use the machine learning algorithms properly. Then it is possible to make predictions for unknown scenario. Now you need to have lot of data. So you basically need data bank for applying ML. Two examples are presented to propose a methodology on utilizing a large amount of past machining data. The first case involves collection of veracious data from various sources. The second case involves efficient storage and prediction. That means two main issues are there, that how to collect the data. Veracious means reliable data from various sources, and other thing is that if you have obtained the data, then how it can be stored in an efficient manner. So these two issues are can make that that two examples of that work in that machine learning area. That first is the collection of the data, second is that efficient storage. Now regarding the machine learning algorithms or methods of machine learning, there are three type of methods: supervised learning, unsupervised learning, reinforcement learning. We will tell about each and every one in detail. Basically in the supervised learning, you have input and output, that pair is there. So you have been given, and you based on that you train and then finally make a prediction. A simple example is that, very simple, that suppose you have x and y data is there. Somebody has given x1, y1, x2, y2, x3, y3, like that, x4, y4. So based on this data you can fit a straight line and you can predict for unknown situation. So such type of thing is basically supervised learning, because it is supervising you that when x is this, then this is this thing. Unsupervised learning, in this you have only the some data, but there is no input output, only some just data is there. That suppose you are from machine, some signals are coming, okay, there is no output, but there are signals coming, okay. So in once you got this type of signal, next you got this type of signal, maybe next you started getting this type of signal. So machine learning algorithm automatically will find out that these two are in the same pattern, they are same, but this is different. So this type of thing will be unsupervised learning. What is reinforcement learning, which is somewhat difficult to understand, but you will understand by this example. Reinforcement learning is type of machine learning where an agent learns to make decisions in a dynamic environment to maximize a reward signal. It is like teaching an AI to play a game or drive a car by rewarding good actions and penalizing bad ones. The agent learns through trial and error, interacting with its environment and receiving feedback based on its action. Like you learn driving the car, maybe you don't have any data or something, but you know that when you did this way, then your car was moving away from the road. So you understand that no, I have to do like that. So you keep getting the feedback, and based on that you take a decision. We will give one example of that just later on. So basically, if we say that machine learning techniques, so one is the supervised learning and other is the unsupervised learning. These are two main classes. Okay, reinforcement learning I will tell later. So in the supervised learning, like regression, suppose you have some data, I have collected various information about say customers' age, gender, economic level, and based on I am predicting that how much will be the demand. So if I am doing like that, so I can have this one. Suppose this is the demand of the product, it is dependent on so many things. So we can say y is equal to C1 plus C2x plus C3y plus C4z, like that, or any other type of equation I can fit, and I have given a lot of data. Based on that I can do the fitting and then I can do prediction. So this is called regression. You have linear regression, you have multiple linear regression, or I have that type of situation classification, that you know that classification means that suppose I give that say names, suppose names are there, just Sita. So Sita, and I also mention that in supervised that Sita is a female, and then I say Ram, Ram is a male, and then I say Rahim, Rahim is a male, Afsana, Afsana is a female, like that. I have given a lot of this type of data, and so it understood that when the name is like this, then it should be female, like Sita, mostly at the end A is coming, so it must be female, like that. It can discover the patterns, and therefore it basically, when I give the unknown name, then it can identify whether it is a female or male. So there is a female, this is male, suppose this is male M, this is female F. So it can either classify in male or female. Similarly, if I show many pictures, it can identify whether it is a fruit or it is a vegetable. So this is called classification. This is also example of supervised learning, because I am giving the not only the picture, but initially for training purpose I am telling that whether it is a fruit or vegetable. Later on I will give of course the unknown data. In the unsupervised learning can be like clustering. You give the data, it automatic makes cluster, that you know that if you give that say different type of suppose you give the say let us say birds and animals, but you don't mention that which is bird, which is animal, and it can say that okay, they look similar, so they may be one cluster. All animals may be put like that. Maybe by seeing that 4 legs, they understood that these are 4-legged animal, and if they are all birds means feathers. So based on that they can say birds. It may not, it may give the name or not give the name, but mostly it makes the clusters. And association will tell you that what is the relation between the data and variables, like it's something, it can tell some rule type of thing, that you will, whenever that this thing is high, then another thing becomes also high. That type of rule it can discover, that is unsupervised learning. So how machine learning learn? That means you have input data, then you have got algorithm, then you give input data, then decide which algorithm you will use, then you will learn, and then you will predict, and it will workflow is like that. You have to collect data collection, then you have to clean the data, remove the dirty and non-reliable data and pre-process, then you do model training, then you do model evaluation, and then you deploy in the practice. Okay. So, data is the foundation of machine learning. You need basically data, you are dependent on the data, and it can be structured versus unstructured data. Data can be in the proper structured way, that you just have example of structured data like we give in the form of a table, this is x, this is y, okay, or maybe usually people used to collect census data, there you have name of the person, then age and other things, there may be many columns, but this is structured. Unstructured data means it can be, there is no set pattern, sometimes in some cases you get some number, in some cases you do not get person's name, but you get only photograph, in some cases voice. So, many type of things are there, and quality data is crucial. Unless you get good data, you cannot use the machine learning effectively, otherwise junk in junk out type of situation will occur. So, supervised learning, as I said, that it learns from label data. What do we mean by label data? Means there is one label, this is input, this is output. Okay. So, it predicts outcomes based on input output pairs. I know that for 10 cases I have told that when this was input, this was output, and therefore for 11th case you can tell that what will be the output 11th. So, example is spam detection, that suppose it has been trained, it has been shown so many emails, and later on it has been told also there that time that which one is spam, which one is real. So, it understood that okay, such type of mails are generally spam, in which we advertise some product aggressively or anything like that. Similarly, price prediction, you know that suppose I give the data and I say that I give the data like you say city, and I can give the month, and then I can say the price of the product there. So, if I give that this type of data, so price is output, this is a label, that means city and month, they are two variables, that means price depends on city and in which month you are purchasing. So, with this type of thing, so it is a label data, because city and month have been labeled with some price. Okay. So, this is part of supervised learning. Unsupervised learning, it finds patterns in unlabeled data, like there is no, it finds hidden pattern automatically, like customer segmentation, the customers purchase, you make the classification that these some customers are similar. Anomaly detection, that machine is running, it is just churning out data, and you collect that data and say that it identifies that today there is some anomaly, because it is not like that previous type of thing. So, this is unsupervised learning. Reinforcement learning, basically learning by trial and error. It learns by interacting with environment. Example can be game playing, robotics and self-driving cars. I think I must give one example which I generated by using one AI tool. It is that example is teaching a robot to clean a room. So, this will be done by reinforcement learning. So, imagine a robot vacuum cleaner that needs to learn how to clean a room efficiently. It does not know how to do it at first. So, we use reinforcement learning to train it. So, environment is that room basically with furniture and dirt in various places, that is environment. Agent is the robot vacuum cleaner, that who is doing the job. States is that different situations, like robot is near the wall, that is one state, robot sees dirt under a table, robot is stuck in a corner, these are states. And actions, robot can move forward, it turn left or right, it can stop, it can start cleaning. And we can give reinforcement learning, means here we reinforced learning. So, we give reward, we define rewards like this: plus 10 points for cleaning a dirty spot. Suppose it cleans properly, we say okay, plus 10 points. So, it understands that this is okay. Minus 5 points for bumping into furniture. If it bumps into furniture, we give minus 5, and minus 1 point for wasting battery without cleaning. That means it is running, but there is no cleaning. So, learning process, at first the robot moves randomly, but whenever it cleans a stop, it gets positive reward. whenever it bumps into something, it gets a negative reward. It understands that no, I don't have to do like that. Over time, it learns which action in which situation gives more reward, and it starts avoiding obstacles, going straight to dirty areas and using less battery. So, this is done by reinforcement learning. So, supervised learning means using label data, it predict outcomes. Unsupervised learning, unlabeled data, discover structure, what is the structure, and reinforcement learned by trial and error. Label data refers to information that has been assigned one or more labels to provide context and meaning. These labels act as a target for machine learning models. So, we can say in supervised learning, there is a target that you know that with this input, this output has to be achieved. In unsupervised learning, this is target free. So, basically these labels act as a target for machine learning models, enabling them to learn and make predictions based on the input data. For example, in image recognition, a photo might be labeled as dog or cat, while in spam detection an email might be labeled as spam or not spam. So, in a typical machine learning one, you have to define problem, then collect data, then train model, then you have to model has to be tested and you have to be deployed. Now, there are two things that you know that you have to train some model and you have to test it. Here there is some confusion in the literature sometimes. Sometimes people say that we need some data for training by which the model is trained, and then we say testing. Now, testing is done to just choose among that whether your model is proper or not, and then finally once it has been done, that means the model has been decided, then you can validate also. But some people use this terminology, then they say training and they say cross validation. These two things are used to make a model, and finally that you know that here they say that here it is testing. Finally, they test that efficiency of the model. Okay. So, example is that if I have say some data, training data, let us say that suppose I have taken some training data, based on that I just try to fit this type of curve, and then I say that in unknown data, testing data, how did it fail. So, if it is if did not fail properly, then naturally I can modify my curve, I can say it was not like that. So, we should avoid that underfitting, that means we should fit the proper polynomial. It should not be that if we have got fitting is not proper, and in the overfitting we try to reduce the error, training error too much, that it even if there is one outlier, I am overfitting it. Okay, I am also counting it that in fact I am doing like this, that here this point is also there. So, I am doing like this here, I am trying to do like this, which is, so this is called overfitting. Then here with training data it is fitted very properly, but with unknown data there will be huge amount of error. This is called overfitting. So, now there are some, how do you calculate find out the performance of a machine learning algorithm. So, there generally we make some confusion matrix. Okay, this is, suppose we have labeled two things, that this is non-failure and this is failure of a machine, and these are the two labels. So, that means this is predicted, this is true. So, that means in 44 cases there was no failure, and it shows that there is no failure. So, this is 44. So, this is why I have put it here, and but in 12 cases machine failed, and it showed also that it failed both the things, that prediction was also 12. But one case was there that prediction was that machine failed, but actually the two situation was not failed. And similarly, there were 0 cases that where machine did not fail and it did not, and it was say machine failed and it was predicted as not failed, that was like that. So, different type of algorithms may give different type of confusion matrix, and based on that you can know the performance of that this one machine learning algorithm. So, accuracy is that it is a percentage of all cases that have been predicted correctly. So, we say total positive cases, total negative cases, divided by total positive, total negative, true negative, true positive, true negative, false positive, false negative. And precision means that we have true positive, but true positive plus false positive, that will give you precision. And recall means true positive, true positive plus false negative, this will give sensitivity. And F score is something that it is a precision and recall, it is harmonic mean of both, and it is written as 2 into precision into recall divided by precision plus recall. So these type of things are there. We will give numerical examples based on that. And so supervised learning algorithms, there are many algorithms like linear regression, logistic regression, decision tree, random forest, k nearest neighbor, and support vector machines. So we will not spend much time on each of that, but just we will pass through that. Linear regression, it predicts continuous data, example predicting house prices based on size. Logistic regression is also there, it is used for binary classification, example is spam detection, whether mail is spam or not. Decision tree, it is a flow chart like model, tree like model of decisions, it is easy to interpret and visualize. Random forest is basically a combination of many decision trees, it reduces overfitting, improves accuracy, it is more accurate. So random forest basically is a combination of that thing. Here you can have many decision trees and you make the predictions for all of them. Finally you take the mean of all predictions and then you can say that this is random forest prediction. And classification is based on, classifies based on closest training example. So k nearest neighborhood algorithm is there. Then support over vector machine, it finds the optimal boundary between classes. I can graphically I show that here suppose y and suppose x, and you have some data, this is this one, this is like this, like this, like this. So we can make some boundary that so that we can classify. Say maybe we can say that in this side this is one and this is one boundary. So here we have all circles and here we have crosses. So it finds best decision boundary. It is good for complex problem. Unsupervised algorithms can be k-means clustering, hierarchical clustering, and we can have many such type of things. We also do principal component analysis. If we have got a lot of the variables and lot of data, by using the principal component analysis you can reduce the dimension. You can find out that which things are more accurate. You can transform the variables and you can make that type of thing. So this is it is based on the eigen value theory, but you know we will not discuss in much detail right now. Reinforcement algorithms are also there, in which Q learning and deep Q networks are there. So all these things you can get. And applications of ML in daily life, it can be used as a voice assistant. In healthcare, it can detect the disease. In finance, it can detect the fraud, etc. In agriculture, you can have yield predictions. And in manufacturing and engineering, it can be used for quality control, it can be used for performance estimation in manufacturing, it can be used for tool machine condition monitoring, it can be used for fault diagnosis, it can be used for image recognition, for quality control, it can be used for time series forecasting. Challenges in ML, that means data privacy issue is there, bias in data and interpretability of models. So there are many ethical issues like privacy, data security, transparency, all those type of things are there. But we will conclude our talk here on machine learning right now, and we will discuss next topic in the next class. Okay, thank you.